Alright, I hit the wrong button, so this is circuit on the mean value theorem take 2, which is just an extension of that first one. So I'm just going to continue on with a couple of the other problems. So I clicked the wrong button, I'm sorry for that. Hopefully you stuck around. So here we go. We're going to go over this problem, which is the piecewise defined. Alright. So when I do this, this is a little interesting problem here. So what we have to do, first of all, is it continuous? Okay. So we check to see if x squared is equal to 2x minus 1 at x equals 1. Okay, so it is continuous. So what we have to do, though, is we now have to check to see if it's differentiable. So what I want to do is I want to check the limit as x approaches 1 from the left and check the limit as x approaches 1 from the right. Now when I check the limit as x approaches 1 from the left, it goes to 1, and when I check it from the right, it goes to 1. So both of those go to 1. Therefore, it kind of, between 1 and 4, if you graphed it, would look kind of like it'll go up to this point and then it'll be a straight line. So what'll happen is it'll look like a Nike symbol, but at this point at x equals 1, it is going to be connected, and the slopes of these two are going to be the same at that point. Okay, so that's the most important thing. Of the slopes. So we have to check 2x and we have to check 2. So when I plug in that, we get 2 and we get 2. So the slope here is 2. I don't want that slope. I want to know there's a slope here, so I need to know what that is. And then I need to find the parallel line that goes along with that. So what we are going to do is, let me find this on my work, we are going to know that the derivatives, y primes, are going to be 2x and 2. And we know that the slopes are going to be the same there. Perfect. We're going to take f of 4 minus f of negative 1 and divide by 4 minus a negative 1, which is, this is 7 minus 1 over 5. Because it is a continuous function, I can do this part over 5, which gives me 6 over 5. Alright, so I'm not looking at this part. 6 over 5 is greater than 1, so it satisfies this part. I have to check that it hits that part too. So I'm going to set that equal to the derivative of that one. And so I get x is equal to 6 over 5 divided by 2, which is 3 over 5. There's the other one that hits that. Okay. One more. This one with the absolute value. This one, if you notice, if I solve this for 0, it comes out to be x equals negative 2. And at x equals negative 2 is going to be your vertex. So your vertex of that, this is going to be this function. And between 0 and negative 4, it is not differentiable here, because it is a sharp point. So that one is the non-differentiable one, because negative 2 is in that interval. Okay, so hopefully you've watched both of them. You got 4 of them. If you have any other questions, shoot me an email.